Hello there, 7th graders. This is Mr. Kashi speaking. As you can see, I am not able to be in the classroom today, so we're going to go ahead and do the lesson on 8.1 through video session. And today's schedule is as you see on the board. Hopefully attendance has been taken. Because I'm not there today, I would like to collect the homework and take a look at it myself. Today's lesson is on 8.1, estimating perimeter and area. And there should be some plenty of work time on the homework assignment. It is out of the book as well. The three things that you need out right now are a writing utensil, your notebook or note sheet, and your vocabulary sheet. Those are the three things that you're going to need for taking notes today. If at any time you need to see a previous slide or anything like that, just let the sub know that you need a little stall so you can copy something down off the board, and they should be able to pause it real quick so you can stay on the right page. 8.1 is on estimating perimeter and area. Okay, 8.1's on estimating perimeter and area. Please put the date on there so you know exactly when we took the notes, so it's for easy reference later on when we're reviewing Chapter 8. 8.1, estimating perimeter and area, and the first question I have to ask is, why would we ever estimate? We need to estimate for multiple reasons. A lot of the times in math, we get into this number crunching and just write the answer down and have no idea if our answer makes sense at all in the first place. Okay, so just to give us some rules of thumb here. So the length of a paper clip is about 1 inch long. That gives you a little bit of a image of how you can estimate how long 1 inch is. And then the length of your textbook is about 1 foot. That would be 12 inches put together. About 1 foot is the length of your textbook. And then the length of a baseball bat is just about a yard. You know, baseball bats range in length, but your normal the wooden baseball bat that you have for, like, you know, professional baseball and all that kind of stuff, that would be about a yard. Not exactly a yard, but right around there to give you a sense of the lengths of these three different customary measurements. The next thing I would like to do is I would like you to estimate the width of the room. Now, you should be able to do that without having to get up and do anything. You should be able to look and say, oh, well, that is about how many feet, how many yards. Okay, if you want to take a look real quick and just write down what you think the estimate is on your notes. You can think about it in how many baseball bats could I fit along the back wall, or how many textbooks could I line up to so we would know the distance from one wall to the other. Okay, so it would be the wall from the blackboard all the way to the wall with the window on it. Okay, and my estimate would be somewhere right around about 30 feet. 30 feet, or that would be the equivalent of 10 yards. One of those two, right around there. It could be a little less in the high 20s, or it could be a little bit more in the low to mid 30s, but I would say a good estimate would be 30 feet or 10 yards. Maybe even a little bit longer than that. Okay? Now, I just want to go over some reasonable estimates. A lot of the times what's going to happen is you are going to be given two options, and then you need to choose the right estimate for that. Okay, so I'll give you a little bit of time to write that down. I want you to write in your notebook the length of a new pencil, 9 inches or 9 feet. This is a rather simple problem for a lot of you. Obviously, a pencil is not 9 feet long, but it would be 9 inches. Okay, we need to get this certain estimate down, because there's a lot of you that once you start number crunching, you might put 9 feet down for the estimate of a length of a pencil and not even know it. You have to understand the problem. So write that in your notes. The length of a new pencil, 9 inches or 9 feet, and then circle 9 inches. Next one, the height of a flagpole, is that going to be 10 inches or 10 yards? Well, if you write that in your notebook, the height of a flagpole, well, 10 inches wouldn't even make any sense. 10 inches, that's not even a foot high, but obviously 10 yards would make a little bit more, make a lot more sense to be the height of a flagpole. So this is probably the simplest thing that we can do in 8.1, but I don't want you guys to get ahead of yourselves because Chapter 8 is rather long with vocabulary and some confusing details. Okay, estimating perimeter is the next topic I'm going to talk about. First, we have to understand what perimeter is. I hope by now you understand what estimating is, but perimeter, we need to get on the same page and really use the same definition every day. So if you have your vocab sheet out, I will reveal to you that perimeter is the total distance around a figure. The total distance around a figure. It doesn't necessarily have to be a shape. It doesn't have to be a polygon. It's just a figure. Total distance around a figure. And this is a linear distance. Distance around a figure. Okay? So if we were to estimate the perimeter around the figure here, we would be able to take a look, and just by using the grid, we would understand that, well, 1, 2, 3, 4, 5, 6, 7 units long, and 1, 2, 3, 4, 5 units wide. Okay, now I don't have to really add up anything, or I don't have to count anything more than this. I know that there are going to be 2 sides with the length of 7, and there will be 2 sides with the length of 5. So 14 plus 10, we would get about 24. 24, and they don't really give us units here. We don't know how much one of those squares is worth. So really 24 is the only thing we can do. If you want to say 24 units, that would be fine too. But since they don't give us the units, 24 would just be fine in this case. So as you can see, this blue line right here isn't exactly on the grid, and this red line right here isn't exactly on the grid, but it's close enough. We're finding the estimate here, not an exact perimeter. I'll give you a little bit to put that down, and then we'll be moving on here. Okay, the next thing we're going to do is not just perimeter, but estimating area. Area is a little bit harder concept for students to understand because of the units that come with it. Okay, the definition of area is the number of square units enclosed in a figure. Students seem to forget that when we are finding the area, we are counting up the number of squares that fit inside a figure. Okay, so I'll give you a little bit of time to write that, jot that vocabulary definition down. The number of square units enclosed in a figure. That is what area is. Okay. When we're estimating, usually we're going to get that grid like you saw on the previous page, and just by a rule of thumb, you might want to jot this down. If the square is if the square is more than half shaded, we're going to go ahead and we're going to count it as a full square. And if the shading of the square is less than half, then we're not going to count it. Just so we're kind of playing by the same rules here. If it's more than half shaded, go ahead and count it as a full square unit. But if it's less than half shaded, then don't count it as a full square unit. And look in here, geography. All right. Estimate the area of Lake Superior. Each square represents 900 miles squared. Now this is where it gets a little tricky because this is a very irregular figure. All right. So what I always do is I would count up the squares that I know are fully shaded in. So I would say 1, 2, 3, 4, 5, 6, 7, close enough, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 so far. 26 so far, and then I would go ahead and say, let's say probably 27. That would be more than half. 28, more than half. Over here, 29, more than half. 30, 31, 32, and then, oof, this is kind of a hard call. I would take kind of all that and make that, I would say, 33 squares. Okay, there are 33 squares, and that's an estimate. 33 squares, but as you can see up here in our problem, each square represents 200 square miles. So if there's 33 of them and each of those squares represents 900 square miles, we would have to do 33 times 900, and we would get right around 297,000 square miles. Okay, I put the SQ in for square because that's how many squares are actually in it. Okay, we're counting up the number of 1 by 1 square miles that can fit inside the area that Lake Superior takes up. So we're actually counting the squares inside, not the distance around. Okay, and Lake Superior being a very large lake, 297,000 square miles would be a pretty close estimate for that. Okay, hopefully you understood how each one of these squares does not represent 1 square mile, but 900 square miles as shown in the problem. All right, moving on. Our assignment, which you should have plenty of time to work on, is on page 377. The main dish is 6 through 16. And choose 4 or more evens with that. The side dish would be 18 through 26, and choose 3 or more evens. And the dessert would be 28 through 34. Choose 3 or more evens there as well. I will be taking plenty of questions when I get back tomorrow, and hopefully this video was helpful, and we will clear things up of the questions that you have. So have a good rest of the day, and keep your stick on the ice.